Good morning, good afternoon, good evening, and welcome to a post on why galaxies and solar systems are flat. The answer is not boring, it's kind of interesting. The planets of our solar system orbit the sun in a flat disk shape, and when we see distant galaxies, we see disk shapes with often spiral forms. And if you click on the blog post, you can see some nice pictures. The standard explanation for why solar systems and galaxies have a disk-like shape rather than being more three-dimensional is a bit convoluted and unsatisfying. I have a video from YouTube on this, and I'm going to criticize it. They tell a story of inhomogeneous matter in expanding space, spontaneously forming an ordered pattern in one plane. So at any given moment, a 3D cloud must spin in a preferential direction, and this will cause it to form into a disk, but in 4 dimensions, with the added dimension of time or motion through space. There is no reason to think that a cloud would ever form a disk. That is why I think this explanation is absolute hand-waving nonsense. I think that disks form because space itself is inhomogeneous, and this constrains the motion to 2 spatial dimensions plus an extra temporal dimension. That provides the 3 dimensions necessary for a disk to form. In the story taught in many classrooms, it is assumed that space is flat or uniform prior to the introduction of matter. This is the premise of the cosmic microwave background radiation. The alternative is to assume that there might be pre-existing large-scale inhomogeneities. Galaxies and solar systems might form with an orientation following boundaries between the inhomogeneities. For example, with matter collecting in disks along the surfaces of bubbles. Some of the surfaces would be mostly flat, such that a clean spiral shape would form. Other surfaces would have a saddle shape, creating an S-shaped galaxy. In the language of nonlinear dynamics, these are different types of fixed attractors. And I have a link to some pictures of those and the theory. When I was scrolling through Facebook, I saw a video of a boat powered by soap. And I started thinking about how matter might form on the surfaces of bubbles of space. In such a video, the boat invariably traces out a spiral shape, much like that of a galaxy. This is caused by the interaction of the boat with its own soapy wake, and it is described by a very old theory, hundreds of years old, called the Marangoni effect. And in the blog post, you see some pictures of boats driven by soap and videos. When I saw this, I imagined this happening on the surface of a bubble, as when frost branches out from a stationary imperfection, or when a boat-like imperfection traces out a spiral shape. Here I have in the blog post some nice pictures of frost patterns. You see that different shapes form on a curved surface than on a straight surface. And in the language of entropy, this crystal growth is a negative entropy system. Like life is also a negative entropy system. But a boat leaving a wake behind it is a positive entropy system. And an understanding of this shows you a lot about how entropy works with motion, how energy is transformed. Many times, when young scientists encounter an idea that is not in line with the consensus they were taught in school, they will reflexively label it as crackpottery, because they've been living in a world full of fake news and they don't feel like they can trust anything that isn't expressed in the exact language they first learned. This is the natural response of an intellectual immune system. But real thinking requires breaking past this natural response and evaluating ideas based on first principles. Some people think that there is power in repeating what the group believes, but grown-ups understand that real power comes from being able to look past what the group believes and look at an issue from several perspectives. I think that galaxy shape might be explained by this Marangoni effect, like the boat powered by soap. With an inhomogeneous, bubble-like space that looks like strands of a cosmic web when viewed from a distance, which is the sort of structure that astronomers see when they look through their telescopes. But the idea that space is composed of bubbles with a distribution of discrete length scales tells only an incomplete story for the discrete masses of the solar system. To finish that story, I'll start where an astronomer left off in an answer to the question of how does a planet start to rotate? He concluded that there is no unanimously accepted theory, but there are certainly other factors besides protoplanetary disk at work, as though this word, protoplanetary disk, explains anything. They say that after the protoplanetary disk forms, you have globs of matter swirling around a central point, like dirt swirling around on the surface of water. Why would this act like a surface of water if space itself didn't already have some sort of inhomogeneity? Why would these globs start to spin and stick together? Well, gravity and conservation of momentum, of course, but how would that happen? If we use what we know about moving charges and how they interact with their own electromagnetic fields, we can make an analogy with how a moving mass would interact with its own gravitational field. These sorts of problems are typically described in electromagnetism with lienard-wiechert potentials, an idea from the 1800s, back when physics was more unified in its conceptual basis. In this framework, a glob of matter orbiting a sun emits gravitational waves propagating at the speed of light. These waves travel in a straight line, forming a chord with the glob's curved trajectory. The glob's longer, slower, curved path causes it to trail the gravitational wave and experience its wake. You can think of the glob as a boat for which the wake is faster than the boat. The boat is turning into the wake, causing the front of the boat to go up and the back to tilt down. This would cause the head of the boat to gain, or the glob of matter, to gain energy relative to the tail, imparting relative motion of the head and tail. For a glob that is not stuck together by gravity, this would break it into smaller pieces. But for a rigid body like a planet, this would impart spin about an axis perpendicular to the direction of motion. If the spinning matter carries a charge and creates a current loop like a dynamo, this will create a magnetic field with the north pole of the planet pointed directly towards the sun. If, due to similar motions about the solar system's center of mass, the sun also has a magnetic field, this will interact with the planet's magnetic field. I like to imagine a bunch of balls rolling on a spinning disc, like something I saw in a local children's museum. As those balls turn into dynamos, the magnetic field of the sun rotates them so that they are spinning like tops on the disc. From a quantum perspective, the mass traveling around the sun is emitting and absorbing gravitons that are analogous to photons in the lienard-wiechert treatment of a relativistic electron traveling on a curved trajectory. This self-similar picture gives a sense of the fractal nature of our universe. Collective effects, or emergent effects, or how order emerges from disorder, also plays a role in how planets form. Systems often have resonances which define how objects will organize themselves. For example, if you oscillate electrons of a given energy up and down over and over, they will organize themselves in a regular ordered pattern. There must be something similar going on in solar systems. To turn this mental animation into scientific knowledge, we would need a good simulation and some measurements, which shouldn't be too hard to do. Some people get the impression that I am contrarian about all of physics, but this isn't really the case. I am merely contrarian about the fragmentation and compartmentalization of physics. I like forming coherent narratives about how things came to be the way they are, and I find that the stories physics tells today are lacking in consistency and dimension. People are allowed to learn fragments of the mathematics, but they are losing the layer of narrative that draws it all together and makes it more interesting. Thank you for watching. Please tune in for my next video. Until next time.